Welcome to Lesson 8.7, Exponential Function. So an exponential function is where we have the variable in, you guessed it, the exponent. So they're often set up as a times b to the x. And again, notice how that x is in the exponent here. And you see a few examples. So let's see and use these in action a little here. So in our first example, we are asked to evaluate this exponential function, which is y equals 3 to the x, okay? And we're going to replace x with 2, 3, and 4. So we have y equals 3 squared, because notice how we replace the x with a 2, and then y equals 3 to the third, and y equals 3 to the fourth. Remember, we have used that f of x as our y. And we could also rewrite these just like that. We could say f of 2 equals 3 squared there. And you can see how we're replacing the x with the 2. And then, of course, all of these we can simplify down to get our y's. And our y's are just going to be 9, 27, and 81 once we've simplified them. Okay, let's look at a real-world example of exponential functions. So in this case here, we've got 2 mice living in a barn, and the number of mice quadruples every 3 months. So the function f of x equals 2 times 4 to the x, okay? And you're going to see, and we're going to do a couple of examples in our next lesson, creating these exponential functions in which our initial value is 2 because we have 2 mice, and then we're told that they quadruple every 3 months. Okay, so we have this function, and we're going to replace the x with what number? Now, since it quadruples every 3 months, and we want to know how many mice are in the barn after 2 years. I want you to think about how many 3-month segments are in 2 years. And that's what we're going to replace that x with. And in that case, it's 8. So there are 8 what I would call generations or cycles happening in that 2 years in which the mice are going to quadruple. So it's going to be multiplied by 4, and then those mice are going to be multiplied by 4 again. So we replace it with the 8 there. And now we have 2 times 4 to the 8th. And then we can punch that into our calculator. And when we punch that into the calculator, we get f of 8, okay, because that's the 8 times that we've quadrupled our mice, gives us 131,072 mice. Okay, that's a lot of mice. But again, we are taking those initial 2 mice, and every 3 months we're multiplying however many mice are there by 4. So here we have another exponential function in which we've got f of x, okay, fancy y, equals 1.25 to the x. And so we're asked to replace the x with 1, 2, 3, 4, 5. And so again, all we're going to do then is take 1.25 to the first power, 1.25 to the second power, 1.25 to the third, fourth, and fifth. And then we're going to graph that. Okay, you can enter these into your graphing calculator as well to see what's happening. And notice it's not obviously going to be a linear relationship, but we're going to see that curve. And here is the curve that is happening, and almost all exponential functions in which we are growing, and that'll be another thing we'll talk about in our next lesson, are going to curve up. Okay, and so you're going to see that nonlinear progression there.